A motorist just had an accident. The accident is minor with probability 0.75 and is otherwise major. Let P be a positive constant. If the accident is minor, then loss is uniform on 0B. If the accident is major, then the loss is uniform on B to 3B. The median loss amount due to this accident is 672. Calculate the mean loss amount due to this accident. So here's a picture. So minor accident, the loss is 0 to B, and the probability of a minor accident is 0.75. So it means the probability from 0 to 0.75 covers the loss from 0 to B. And then there's 0.2 for remaining probability is that the loss will be between B and 3B. The remaining probability would be 0.25 over here. So we are given that the median is 672, and the median is the point where the cumulative probability is 0.5. So that's the median point. So therefore, median lies in the portion of the loss that is between 0 and B. And so 0.5 is the probability that x is the loss, that x is less than or equal to 672. And normally, if you imagine you just had this portion from 0 to 0.75, imagine this was your whole uniform distribution. So then you know that the loss will be that the probability that x is less than or equal to 672 would be, by interpolation, 672 minus 0. That's the portion which is less than 672 divided by the total length of the interval, that's b minus 0. So that's what we would do if 0 to 0.75 was our whole interval. 0 to b was our complete interval. But this is a situation where we don't just have 0 to b, we also have a portion from b to 3b. So we know that this 672 business is happening in the 0 to b. So we need the probability that we are between 0 to b, and that probability is 0.75. So therefore, so normally, like I said, that if 0 to b was our whole interval, then we don't have this factor lying, because you definitely are in the whole interval. Here, x would be less than or equal to 672 if x is in this interval 0 to b to begin with, which is probability 0.75 and means multiplication. And then not only is it in this interval, but it's also less than 672. So probability less than 672 equals the product of the probability being in the interval to begin with, and then this other normal thing which we always have. So 0.75 times 672 over b, and that's 504 over b, and that's equal to 0.5. So that gives us b is equal to 504 over 0.5 equals 1008. So now we have to find the expected value of the loss, because mean loss means expected value of the loss. And expected value of the loss by law of total probability is equal to probability of a minor accident times expected value of the loss given a minor accident, plus probability of a major accident times expected value of the loss given major accidents, as minor and major accidents are mutually exclusive and they cover every situation of an accident. So we would do the expected value in case of a minor accident times probability of minor accident plus expected value in case of a major accident times probability of major accident. So probability of a minor accident is given to be 0.75, and the expected value of x given a minor accident means the expected value for the 0 to b interval, uniform, and major accident probability would be 0.25. Since minor is 0.75, the remaining will be major. And expected value in case of major accident, we are between B and 3B. And now we know that for a uniform distribution, the expected value lies at the midpoint of the interval. So the expected value of 0 to B would be 0 plus B by 2. And the expected value of B to 3B would be B plus 3B by 2. So when we do all the simplification here, we get 0.875B and B is 1008. And so that comes out to be 882, which is choice D.